Welcome to Data Do Library. In today's video, we will review the first 3 chapters of Ron Larson's Pre-Calculus 10th edition book. The first chapters are Functions and Graphs, Polynomial and Rational Functions, and Exponential and Logarithmic Functions. Let's begin. In this first question, we have to find the slope of the line passing through the pair of 2 points. You may recall that the slope of a line is found using the following formula. M, which is slope, is y2 minus y1 over x2 minus x1. Now we're going to identify our points. Doesn't matter which one you choose as your first point, which one you choose as second, it's all the same. But we're just going to call this my x1, y1, and my x2, y2. So plugging it into the formula, I have y2, which is negative 6, minus y1, which is 0, divided by x2, which is 0, minus x1, which is 10, giving me negative 6 over negative 10. Two negatives make a positive, and we will reduce 6 over 10 to 3 over 5. In this question, we have to determine whether the lines are parallel, perpendicular, or neither. The way we're going to do it is to identify their slopes. If the slopes are the same, exactly the same, these two lines are parallel. If they are perpendicular, their slopes will be opposite reciprocal, and if neither, obviously neither of those apply. So the slope of line 1 is the number that stands in front of x, which is 1/2. That is slope 1. Slope 2, number that stands in front of x, is 2 over 1, or just 2. Notice these two slopes are definitely not the same, therefore these two lines are not parallel. They are reciprocal, but they're not opposite. Therefore, the answer to this question is neither. In this question, we are asked to find what is the value of the function at a certain point. In this case, we're using t as our variable. Therefore, the numbers or the expressions that are inside of the parentheses will replace the variable, in this case t, everywhere you see a t. So I'm going to replace it in those two spots. So in this first one, I have to find h of 4. In other words, I'm going to plug in a 4 everywhere I see a t. So I have negative from the formula, 4 squared plus 4 plus 1. Now that 4 gets squared, but the negative does not. Therefore, I have negative from the formula. 4 squared is 16, plus 4 plus 1 is negative 11. In the second part, I have to do the same thing, just with negative 1 and for t. Therefore, I have negative from the formula. T becomes negative 1. I'm going to square that, plus negative 1 plus 1. So negative again comes from the formula. Negative 1 squared is positive 1. Plus and a minus will turn into a minus 1 plus 1, which is negative 1. What this means is that there is a point on this function, in this case it's an upside down parabola, that has coordinates of negative 1 comma negative 1, or 4 comma negative 11 in the first part. In the last part, we have to plug in x plus 1 in for t. So I have to find h of x plus 1. I have negative from the formula. X plus 1 will get squared. I'm going to add x plus 1, and then I'm going to add plus 1 again from the formula from here. Negative comes along for the ride. X plus 1 squared. One most common mistake is to distribute this square through the parenthesis and call it a day. That is incorrect. What you have to do is FOIL. So on the side, I would suggest foiling this. X plus 1 times x plus 1 will give me x squared plus x plus another x plus 1. First, outer, inner, last. I'm going to combine like terms, and I have x squared plus 2x plus 1. Now notice I put parentheses around this because there is that negative from the formula that's going to distribute through that parenthesis. Very common mistake as well. Here I have plus, so I can just drop the parentheses, and then I have plus 1. So again, I'm going to distribute this negative through this parenthesis, which will give me negative x squared minus 2x minus 1 plus x plus 1 plus 1. Now I'm going to combine like terms. Negative x squared does not get combined with anything, it's just there by itself. Therefore I have negative x squared, negative 2x, and positive x will be put together. Therefore I have negative x. Negative 1 plus 1 will go away, leaving me with plus 1. And that is my answer. In this question, we are asked to find the domain of this function. And the only places that the domain will not exist is when the denominator is equal to 0. So when can the bottom, x squared minus 6x, equal to 0? So I can factor out the x here, because it's in common to both, and have something like this. Now I'm going to set each one of them equal to 0. So x equals 0 and x equals 6. So x minus 6 equals 0. Move the negative 6 over to the other side, giving me 6. These are the two numbers that if I plug them in here, I will get 0 in the denominator, therefore no solution. So we cannot have a 0 in the denominator. Therefore, any number will work except for 0 and 6. In this question, we simply have to use the vertical line test to determine whether this is a function or not. A vertical line test, all I need is one vertical line that passes the function in more than one place. So as long as I can draw one vertical line, and in this case I can draw many of them, that passes the function in more than one place, this is automatically not a function. This question has a few different parts to it. In the first part, you are asked to identify the parent function. The parent function for this would be absolute value of x. As notice the transformations that occur, both inside and outside of the absolute value, will move this parent function in certain directions. So the plus 3 on the inside is going to move it left and right, and it's going to be opposite of what you would think. So you would think the positive makes it go right, it actually makes it go left. So it's left 3, and then the outside number, negative 2 on the outside, will make it go down 2. So looking at the answer choices, I have horizontal shift 3 units to the left. That is one of the possibilities. And then 2 units down, which is a vertical shift of 2 units down. There's no shrink because there is no number in front of the absolute value that multiplies this function. So taking a look at the graphs, we know that absolute value is a v, and it's from its original direction, it's going to go left 3 and down 2, which looks like this graph. In this question, we have to do some composition of functions. First one is f of g of x. I'm going to write it like this, which is the same thing as writing it f of g, like fog. So f of g of x, I'm going to first replace g of x with what g of x equals to, which is x to the 4th. So now this problem really becomes f of x to the 4th. So I'm going to go into my function f of x and replace x with what's inside of here. So instead of writing x, I'm going to write x to the 4th. That's it. In the second one, we have to do the opposite. G of f of x. So again, I'm going to replace f of x with what f of x is equal to. So g of 4x. Now I'm going to go into my function g of x and plug it into the variable there. So instead of x, I'm going to write 4x. And then that function is taken to the 4th power, which would be 256x to the 4th. And last one, what is g of x? which means I'm going to take g of x, I'm going to plug it into itself. So I'm going to take this function g of x, this x to the fourth, and plug it into x to the fourth. In other words, I have x to the fourth taken to the fourth power, and when you're taking a power to another power, you multiply these powers, therefore this is x to the 16th power. In this question, we have transformations again. The number on the inside is going to move it left 3. The number on the outside is going to move it down 2. And it's a parabola because it's an x squared function, which means this would be the correct choice. In this question, we have to write this equation in the standard form. One way to do that is to use completing the square. So I'm going to move the positive 2 over to the other side of the equal sign, so that would give me negative 2. To complete the square, I have to take b over 2 and square it, and then add it to both sides of the equation. So b is just the number that's in front of x. In this case, it's 6 over 2 squared, which is 3 squared, which is 9. So I'm going to add 9 to both sides of this equation. Now I'm going to factor, giving me x minus 3 and x minus 3 on the left side, and on the right side is just simply 7. This x minus 3 can be written as x minus 3 squared equals 7. If I bring that over to the other side, x minus 3 squared minus 7, that will give me an idea of what the transformation is. So minus 3 on the inside is going to move it to the right by 3 units, and then negative 7 on the outside is going to move it down. It is a regular parabola because there is no negative sign in front of x in the original equation. Therefore, our answer is here. In this question, we are asked to use long division to divide two polynomials. So we're going to write out the first polynomial, 4x squared minus 15x minus 54. We're going to divide this by x minus 6. So the first one we have to look at is, what is 4x squared divided by x? Or what do I have to multiply x by to get 4x squared? And that is 4x. So 4x times x is 4x squared. And now I'm going to multiply 4x times negative 6, which is negative 24x. Now, with long division, we have to subtract this polynomial. In other words, we have to change the sign of everything that's inside. So this will become negative and this becomes positive if we just distribute the negative. So these would cancel as we would expect. Negative 15 plus 24x is 9x. Now I'm going to bring the negative 54 down and repeat this process. So what do I have to multiply x by to get 9x? The answer is 9. So I'm going to multiply it by 9, and again I have to multiply everything in here by 9. So 9 times x is, again, 9x. 9 times negative 6 is negative 54. And again, we're going to subtract, which means just change signs. So negative and a positive, and everything cancels out to 0. Therefore, the two polynomials divided will give us the answer of 4x plus 9. In this question, we're asked to use synthetic division instead of long division, which is a much quicker process. The only thing you have to remember is to make sure that every power of x is accounted for. In this case, our degree is x cubed is 3, so we have to make sure x squared, x to the first, and x to the 0 power is accounted for, and if they're not, you fill it in with 0. In this case, they are all accounted for. Therefore, I'm going to write out all the coefficients. 5, negative 47, 27, and negative 81. I'm going to divide that by the result of setting x minus 9 equal to 0. So I'm going to divide it by 9 if I move the 9 over to the other side. So 9 goes in here. Now you're going to bring down the first number. 9 times 5 is 45. Negative 47 plus 45 is -2, and then you repeat that process. Multiply it by 2 and put it here. So -18, 9, 9 times 9 is 81, and that's 0. So our remainder is 0. So what this gives us is what's called a depressed polynomial. In other words, it's just a polynomial of 1 degree less than what you started. So these are my coefficients. Since we started with x cubed as my degree, the new degree will be 5x squared minus 2x plus 9, and again the remainder is 0. So when you divide those two polynomials, this is what you get. Now we will move on to complex numbers and imaginary numbers. So a square root of a negative number is going to produce an I, and I strongly suggest you do this step by step, at least at first. So first we have square root of -27. Since we have a negative inside of square root, we're going to pull an I outside of the square root, and we still have 27. Now we have to think about what 27 can be broken down into. So 27 can be broken down into 9 times 3. And the reason why we do that is because square root of 9 is just a plain old 3. So this can be written as square root of 9 times square root of 3. And as we just said, square root of 9 is 3. Therefore, I have 3i square root of 3. When adding or subtracting imaginary numbers, we have to treat them like a variable. Since we have a negative here in front of this parenthesis, I'm going to distribute that negative through. So I have 5 plus 8i minus 8 minus 19i. Now I'm going to combine like terms, just like I would with variables. So 5 and -8 is -3, and 8i minus 19i is -11i. When multiplying imaginary numbers, one thing to remember is that I squared is equal to -1. So when we multiply these, I have 1 times 8, which is 8. We're going to use FOIL here. 1 times -7i, -7i. I times 8, positive 8i. And I times -7i will give me -7i squared. So again, I'm going to combine these two terms, giving me 8 plus I. And as we said before, I squared is -1. So I can write -7 times, instead of I squared, I'm going to write -1. Now we're just going to simplify. 8 plus I, two negatives make a positive 7. Therefore, 15 plus I is my answer. To find a vertical asymptote, all we have to do is just set the denominator equal to 0. So to find the vertical asymptote, I'm going to set 2 minus x equal to 0 and solve for x. So I'm going to subtract 2, negative x equals -2, x is equal to 2. Therefore, my vertical asymptote is at x equals 2. To find horizontal asymptote, I have to look at the degree of the numerator and the denominator. Degree is just nothing more than the highest power. So the highest power of the numerator is 1, and the highest power of the variable on the denominator is also 1. If those two are the same, all you need is the ratio of the coefficients in front of those powers, in front of those variables. So the horizontal asymptote is just the ratio of those coefficients. So y is equal to, the numerator is positive 1, and the number in front of x in the denominator is -1. Therefore, y equals -1 is my horizontal asymptote. Our last topic is about exponential and logarithmic functions. In this question, we just have to plug numbers in for x, and the function f of x is equal to 10 to the x. So now we'll start here with the middle one, because 10 to the 0 power is obviously 1. Anything to the 0 power is 1. Then I'm going to find f of 1. I'm going to go to the right here. So 10 to the first power is 10, and 10 to the second power is 100. Now with the negatives, f of -1, I have 10 to the negative first power, which is the same thing as 1 over 10 to the first power, which is just 10. So 1/10 goes here. And then f of negative 2 is 10 to the negative second power, which is 1 over 10 to the second power, which is the same thing as 1 over 100. So 1 over 100 goes in this spot. So the graph that matches that is here. To use the one-to-one property when it comes to exponents, you have to make sure that the bases are exactly the same. So the left side we're going to leave alone. The right side, 27 can be written as 3 cubed. Now that the bases are the same, I can say that their exponents are equal. Therefore, x minus 8 is equal to 3 at 8. X is equal to 11. In this question, we have to change the logarithmic equation into an exponential form. You're always going to start with the base, which is 2, and then follow this counterclockwise pattern. So 2 to this power is equal to this. So the base to the second power is equal to 4. And that is just simply writing it in an exponential form. Same applies going backwards. Let's say I had this exponential form and I wanted to write the logarithmic form. I would just say log of base 2, I start here going counterclockwise, of 4 is equal to 2. One-to-one property when it comes to logarithms, you just have to make sure that the base of the logarithm is the same on both sides, and you have only one log on the left side and one log on the right side. If that's the case, you can kind of just forget those logs and say that x minus 1 is equal to 9, add 1, and x equals 10. To evaluate this logarithm using change of base formula, I'm going to exchange it using either natural logs or log of base 10. Whichever one you choose is going to work. So I'm going to use natural log of 19 divided by natural log of 3. The way I remember this is the base goes on the bottom. And now you can just go ahead and type it into your calculator, which gives me 2.680. To check your answer, think about whether this answer makes sense. You can convert this into an exponential function just by taking the base to this power. Therefore, 3 to the x power is equal to 19. Well, 3 to what power is going to give me 19? Well, 3 to the first power is 3. 3 to the second power is 9. And 3 to the third power is 27. I need 19. Therefore, 19 has to fall somewhere in between 9 and 27. In other words, somewhere in between second power and a third power. So 2.68 seems like it makes sense. And to double check, I would just take 3 to the 2.68 power, should give me something close to 19. To expand it, you just have to remember that multiplication turns into addition, division turns into a subtraction. So since we have nothing but multiplication here, I have log base 4 of 11 plus log base 4 of b to the 8th plus log base 4 of c. One other thing you should do is use the power rule of logarithms and use this and take this 8 and move it in the front as my coefficient. So the final answer should be log base 4 of 11 plus 8 log base 4 of b plus log base 4 of c. In this last question, we have to solve this logarithmic equation. The first thing I'm going to do is get rid of this 5 by just simply dividing everything by 5. Therefore, I have log of x minus 8 is equal to 12 over 5. Since I only have one log on the left side and nothing on the right side, one technique to solve this is to turn this into an exponential equation. Since there is no base here, I'm assuming that this is base 10. So I'm going to take base 10 to this power, 12/5 power, is equal to x minus 8. Then I'm going to add 8. So x is going to be whatever I get from putting 10 to the 12/5 power in my calculator, then adding 8, which gives me 259.189. As always, thank you very much for joining me. Don't forget to like and subscribe. See you next time.